then with that streaming key, given message can be encrypted. So encryption process is very simple. Simply we do exclusive OR. Okay, by doing exclusive OR operation, you can get a ciphertext. Once you have a key, because you know exclusive OR, you can get the message very quickly. The only key issue here is that a key is not really static, keep changing. Therefore, it's not doable, right? So that is the key points that we do real-time streaming-based cryptographies. So keep changing this streaming key. Similarly, at the receiver side, the streaming key is also changed, but they are producing the same sequence of the keys, so that given the message, we can encrypt it to restore the original messages. All right. What we will do is that we'll look at RC4, okay, rebest cipher version 4. Originally, it has 256 the size, and then there are two algorithms running. First, the initialization of the permutations. So 256 byte array is going to be used, and then so that'll be an initial vector S, and then maybe T for some keys. Okay. So both should be the same size, 256, so that we run this algorithm, okay, from 0 to 255, therefore that'll be 256 array. And we generate S, okay? And then we assume there is a key that is shared between sender side and receiver side. Okay, so key is given, or key can be generated separately. Okay, so we have two arrays, S and T. Okay, then update S according to this. So keep changing. So there's a 256 iterations. By having J can be updated. So J and then content of the first array. So for each arrays, and then there is some modular altogether addition, and then we have another modular, and that'll be J. So basically what we have here is that we have SJ and SI. So those are swapped, SJ and SI. Then there will be a new S. So new S will go back to another looping. So that can be done how many times? 256 times. And then finally, we have final stage of array S. Then array S will be fed into the next module where that is the streaming, okay? I would say this is a streaming. So RC4 streaming, and what happens is that if we have that S array, which contains all different numbers initially from, and that is given by the previous stage. And here again, we have the looping continually until this is endless loop, right? As far as there is a streaming data, then we keep executing this, okay? But what happens is that this initially I and J are starting from 0, and then there is an index I, right? And I and J goes together. So as I increases, J is also modified, and there's a two modular functions. That should be 256, 256, both 256, and they keep changing. Okay, and then finally swap, and then output will be this. Okay, so that output will be used as a key. There's a one-time key, and then one-time message, and then produce a cipher, and then ship out. At the receiver side, receive it, and then decrypt it by exclusive OR with the key stream. Therefore, the key stream used for encryption that is generated synchronously. It's not really time synchronization, but because they share at the shake hands, so they know the steps to go. So they use the same ones. The algorithm, we will simplify 256 to 8. So 8 by 8 byte arrays will be used. And then size of key also smaller, 4 bytes. And then message again 4 bytes. Okay. So we generate, because we are using 8 bytes array, so 8 from 0 to 7. That's array of S, and array of T is the array 4 keys. So if 4 bytes are given, then we repeat that. Other than that, it may be generated in another algorithm. So what happens here is that once you have S and T, 2 arrays, then we go to the next, the first algorithm, that is initialization. As I said, it'll be iterating 8 times. So we are now talking about 8 bytes long arrays. So initially J is 0 and I is 0. So for I is 0, so this is iteration, right? For I can move from 0 to 7. So at the first stage, for I equals 0, then I is 0, and right now J is also 0. So I and J are 0. Within that for loop block, there's 2 statements. We generate S. We know I at the first loop, we have 0. So S of 0, and whatever the J obtained, so S of J, 2 components are swapped in this S array. So S array will keep changing. Okay. Finally, part of this S array number will be a streaming key. That streaming key will be exclusive or with 1 byte of a message. So byte by byte encryption and byte by byte decryption. That is the idea of streaming encryption and decryption. So the first formula here. So we keep computing this formula for each iteration. So I is 0, 0, and J is S of I is S of I, which means S of J, S of not S of 0, S of 0, which is this. So that is 0. J, of course, that is 0, initially 0. So J is 0, S of 0 is 0, and then T of I. So I is 0, so T of 0 is 1. Add them all and modular, then there will be 1. So what happens here is that I is 0, J is 1, so we swap SI and SJ. SI means S0, SJ means S1. So S0 and S1 will be swapped. These 2 will be swapped. All others remains the same. So instead of 0, 1, 2, 3, 4, 5, 6, 7, it'll be 1, 0, and then that. So we keep doing this. So after the first iteration, then we will increase I by 1, right? So I will be 1. So that is this. For I equals 1, for I equals 1. Then next statement is that here, J is updated already here. So J will be 1. I is 1. So S of I is, S of 1 is, S of 1 here, 0. So that goes here. And then this one comes from here. And then T of I is 1, right? So it goes to T. I is 1, there is number 2. number 2 come here. So with the add them all, divided by 8, remnant is 3. So j is now updated. So I is 1, j is 3, so s of I, s of 3, s of 1, s of 3 will be swapped. So s of 1, s of 3, these two will be swapped. Now s of 1, 0, 1, 2, 3. S of 1 and S of 3, these will be swapped. So 1, 3, 1, 3, 3, 2, 0, and that. So having this, that is a completion of the second iteration. Now we go to the third iteration, which is j equals to 2. We plugged here. So what is j currently? J is 3. What is S of I? S of I means S of 2. S of 2 means here 0, 1, 2. There's a 2. So 3 plus 2, there's a 5. So far 5. And then T sub 2, 0, 1, 2, that is 3. Okay. 5 plus 3, then that'll be 8. So 8 divided by 8, remnant is 0. So that is 0. So what is I? I is 2, j is 0. So S of 2 and S of 2, S of 2 and S of 0. S of 2 and S of 0 will be swapped. So S of 0, S of 2 will be swapped. This and this will be swapped. Therefore, we have 2 and 1. So 2, 3, 1, 0. Okay. Let's go to the next iteration, which is I equals to 3. I equals to 3. Previously, j equals 0. Okay. So this is a 0. I equals to 3, which is j sub 3. So j sub 3 is 0, 1, 2, 3. That is 0. So 0 and 0, right? T sub 3, right? Go back here. T sub 3, 0, 1, 2, 3. T is not changing, right? Key remains the same. So that is a 6. So come back here. So 6 divided by 8, then remnant is a 6. So we need to swap S of 3 and S of 6. S of 3 and S of 6, right? 0 and 6 will be swapped. So this and that is swapped. We keep doing that. In the online lecture in scisecure.org, I want you to enter this. Okay, what is SRA, the iteration of I equals 4 completes. So I want you to enter the number. You don't need to, on that small quiz, you don't need to put square bracket. You don't need to put a comma. Simply list all the numbers in one name. Okay, no space in between. So doing that. So if you do this continually, then at the end you will have this S. Okay, so this will go to the next streaming key phase. When you come here, streaming key phase, another loop. As I said, this is this runs as far as there is message to encrypt, right? So this this will go forever as far as between your laptop and access points are communicating. Steps here is that this I and j is computed by starting with all zeros. I and j will be zeros, right? So once I is updated, then that I will be used here. That affects to j. So I increased, right? I increases because I equals I plus 1 and mods, but it doesn't go forever. Every time it's a remnant. But S of j contains a different number, so that will affect to j. So I and j keep changing. Therefore, we do swapping here. Once we swap and then read for I and j, although S of I, S of j are swapped, I and j on the same iteration, they remains the same. So go back to that Sij's, S of j and S of j, S of I and S of j, and then add them and modulo by 8. And then that will be another index t. So go with that t, we can get the value from that array, S of t. So that will be the key. This key will be used for exclusive OR operation. Okay. So once we have that, then we do this. So that is explained here. So first, I equals 0 and j equals 0 initially. So at this point, I and j is 0. So I 0 plus 1 modulo 2, then I is 1. Immediately I became 1. So S of I means S of 1. When you come back here, S0 and S1. So number 3 will be this. And 0 plus number 3, then that is 3. 3 modulo 8, so that'll be 3. So I equals 1 and j equals 3. They are swapped. S of I, S of j, S of 1, and S of 3. So S of 1, S of 3. This and that will be swapped. So that is this. They are swapped. So once they are swapped, then we will get eventually k. So before we go there, then what we need to do is that, so this is updated, S is updated. We still have same I, same j. So let's go to S of S1, S of 1, and S of 3. So to here, S of 1, S of 3. So 4 plus 3, which is 7. This will be 7. So 7 divided by 8, remnant is 7. So t is updated. That t is not yet the key, but t is the index to the array where there is a key. So if you go to S of 7, go back to the recent S. Back here, S of 7 is the last one, right? So that is 5. Okay, so one key is generated. Therefore, 1 byte can be encrypted. 5 and 1 will be exclusive ORed. So 5 exclusive 1, exclusive over 1. 5 is in binary 101, 1 in binary 001, exclusive OR. Therefore, we have 100, which is nothing but 4. So what happens here is that the original message is 1. And according to the key, streaming key just generated, we have encrypted message. That's 4. We keep doing this, okay? For the next iteration, for next byte of the message, okay? Then key will be generated 1. The next message is 2. So 1 exclusive over 2 equals 3. We keep doing that, right?